Hello, Mark. Thanks for coming on the podcast today. I'm excited to talk to you.
Well, thanks, Cheyenne, and it's a great honor to be on your show, The Underground Antics.
Yeah, it's thanks for coming. It's going to be fun. You recently wrote a book. It's called Age-Decoded. It's a fiction novel about the genetic engineering and what might come of it, and all of the things that, you know, we need to start thinking about and looking into before we sort of engage as a species on this journey of adapting genes and making things different to how they sort of might quote unquote naturally be. But this isn't actually your primary profession. You, as you just said, you recently retired, and before this you were a teacher and a golfer. And so how did you kind of come about writing this book? Like, what inspired you?
Yeah, so you're quite right. I'm not an expert in the area. I'm not a genomicist or a genetic scientist. But I got into this because of my athletic interest, actually. So I'm a triathlete. I'm a serious triathlon competitor. I competed for Canada in the World Championships.
Oh, wow.
In my age group. Luckily, I don't have to compete against the young bucks who are 25 or 30, all those pros. But they do age groups, so I'm in the 60 to 65 grouping. And the guys I compete against I found out they're all fanatics, actually. There's a lot of them are retired, and they do like 2 or 3 workouts a day, and they're biking, swimming, stretching, strengthening, and running, of course. So I noticed that in that age group, even in that 5-year age group, the guys who were 64 or 65 would often talk to the guys who were only 60 or 61, like me. I was in the lower end of that. And they would say, you have a big advantage. You're 4 years younger. And I thought, wow, aren't we all just in our 60s? We're all just old, aren't we? No. Like, they can act, they're so fine-tuned, they can actually feel the decline in their performance over 4 years. Because we're all getting older at that stage, and we're slowing down a little bit each year. And physiologically, they say it might be about 1% of your aerobic capacity per year. So you notice that over 4 years, it's 4%, which could be like over a minute in a 10K run, right? So you actually do feel it. So I started reading about aging and performance and anti-aging. There was some research going on. I started about 10 years ago reading about this. And I noticed that there was a fair amount of actually serious research, not science fiction, but serious research going on into aging and stopping aging and trying to maybe even reverse aging, and a lot of it was genetic engineering science. So that's how I got interested in this. It just started from my triathloning.
Wow. I mean, listen, regardless of whether you're 60 or 65, I mean, doing triathlons at that point is quite an achievement, and, you know, congrats to you and the guys that you compete with. I mean, it's a hell of a thing. I mean, I definitely couldn't do a triathlon now. I mean, I suppose I could train for it, but, you know, just it's marvelous to be able to be at that point. And so that's awesome. And so what kind of research were you interested in? Was it from like a personal perspective in terms of like you didn't like the fact that you were aging and had this decline, or was it just more of a general interest of like, oh, why is this happening? And, you know, what's being done to combat it, and what can we do to improve at that level, or slow down the aging process? Was that the kind of track of thinking? Yeah,
so a combination of both, really. Just an interest in them, personal interest. And so the stuff did jump out at me, and I thought to myself, well, that would be great for triathloning if we could stop that decline, right? That human inevitable decline towards death. But then I thought, well, forget about triathloning. What about our world? What would our world be like if we literally could stop aging and all of the related diseases that go with it, and maybe even start reversing it? So that really blew my mind when I started thinking that. I said, you know what, Mark? And I was the least likely person to write a fiction novel. If I had written anything, I thought it would be nonfiction. I've done a lot of scientific reports and writing on that side, but I've never tried fiction. And in high school, probably my worst subject was English. So I was motivated by that crazy. I guess it was almost like a an enlightenment about this topic, and just trying to speculate into the future. So in my novel, that's what it is. It's a speculation. It's not what I call fantasy science fiction. It's more like what they call hard science fiction or speculative fiction, where I try to extrapolate from today. I try to use all the science that's going on right now and move into the future and try to predict what actually I think is going to happen.
Right. Yeah, and that's very interesting, and it's an important distinction, right? Because with fiction, you're given liberty to create anything you want. I mean, it doesn't have to, abide by the laws of physics or chemistry or thermodynamics, and you can basically make it up, and that's all good. There's a space for it, and science fiction is huge and popular, and people love it, and it's entertaining, and so
yes.
It's interesting that you took the approach of the hard fiction to really say, well, this is speculating on basically where it looks like we're headed, right?
Yes, exactly.
And it's a more like realistic view of what might come, and just where things are going to go. And the technology that's around at the moment is already remarkable with genetic engineering. And I know that, for a lot of things that are still in very early, like research and development stages, and it's controversial, to say the least. And, people will have mixed feelings about it. But there's place, as you have said, and in the book, where it's like, well, like everything, there's going to be good parts and there's going to be bad parts to it, right? And like the phrase goes, with great power comes great responsibility, right?
Yeah, that's really well put, Shane. You've hit the nail on the head there. So
yeah, and it's also interesting because, as far as I know, there's no animal or plant species in the world that doesn't die, except for, I think there's a jellyfish that sort of somehow reverts to an primordial phase of its development and then sort of grows up again and kind of just reincarnates itself. But other than that, I mean, everything that is alive is going to die pretty much. And so it's a really interesting thought to be able to say, well, what happens if we don't do this and we can live for 1,000 years or 5,000 years or whatever it is? I mean, I suppose in the end, like, you're going to die anyway, like the sun will explode and whatnot. And so you might prolong it a little bit, get a few more triathlons in, but yes. the end is coming. But so what have you found, like, in terms of what's the latest in the science literature on genetic engineering? Like, what are people feeling about what's happening, and what are the sort of like what are some of the things that you think we'll see in the near future, the next few years?
Well, I'm pretty positive, even though my novel is somewhat dystopian, but it doesn't end up totally dystopian. There are some good things that happen, but it has a dystopian feel to it most of the way through. But I'm still personally very positive on things that are going to happen in the very near future, even things that are happening right now. So, and I can hardly keep up with the breakthroughs and the readings. It's just it's a tsunami right now. Tsunami is just about to hit. We're on the threshold. So a couple of examples. The University College London and also UC Irvine in California are both involved in genetically modifying mosquitoes. We could be talking about genetic engineering of any living species. This is to help humans, though. So what they want to do is change the mosquitoes so that they cannot conduct malaria and dengue and yellow fever and other things that hurt humans. So they actually just released a bunch of these genetically modified mosquitoes in the Florida Keys, and just a few weeks ago, and we'll see how that goes. They're designed to drive out the bad mosquitoes, and so we'll see how that goes. But that's a big experiment. Maybe another example would be using on the human front is that actually just came out a few weeks ago. Dr. Gilmore, again, University College London, I believe, came out with a breakthrough. Really, he's got it. There's a very rare liver disorder, but it's also very debilitating. And basically, the liver produces a protein which causes the human's nerves to break down, and it's a horrible disease, but it's pretty rare.
Fun.
But anyway, they wanted to take a shot at it. So what they did is they took 4 subjects, and they, for the first time that I know of, they injected substance into the blood of the people, just to generally enter their blood, but then it was directed to proceed to the liver. So it zeroes in into the liver, and then in the liver it does genetic engineering, editing of the liver cells that cause that protein problem, and evidently it's working. So that's pretty cool, because that's getting very specific, targeting specific tissues, so you don't have to affect the whole body or the sperm cells or anything else. You can zero in on where the problem is and do your genetic engineering. And that CRISPR engineering is the hot technique right now. The Nobel Prize was awarded for that in 2020 to two female researchers, Jennifer Doudna and Emmanuelle Charpentier. They didn't perfect the technique, but they really improved it vastly, so they got the Nobel for that. So that's a couple examples of things that could help humans, and are already helping humans.
Yeah, and I suppose it's a good point to make of like how genetic engineering can be applied to all kinds of living species that have, I guess everything that's alive has genes, right, and DNA, and so it can be altered and in various ways. And so, could you perhaps give a little explanation of how the CRISPR technology works?
Sure. So it's a mechanism that it's sort of like operates like a virus, and it I think they found it in bacteria actually to protect it from viruses. So anyway, it's a mechanism, but then it also hooks onto nanobodies, which then direct itself to DNA. So they can be very specific in this. So it'll go to the DNA area within the genes, and it will edit the DNA. So it can cut things out, it can add things in, it can replace stuff, patch stuff up. It's literally like editing a document, like we would on a Word document or something, changing words or whatever, and replacing stuff. And it's not perfect. It does have some little side effects because you're in there, and there's some residual effects, and they're working on that, trying to make it even more exact. And they don't want, of course, unintended consequences, right? So so it's literally editing the genetic code, and we have I think it's 3 billion pairs of nucleotides in our DNA. So there's lots of stuff that can be edited. And also, like, I didn't know this till a few months ago, but there's also research going on into not just changing your genes, but changing what's called the epigenome, which is around the genes, and that's a sort of a separate thing but related. So it's, instead of changing the genes, you're changing how the gene is expressed through the body. It almost like saying you're not changing the book, but you're changing the reader and how they interpret the book.
Right.
Okay? And that's a whole other thing that's going on, and there's very exciting research. Steve Horvath at UCLA, David Sinclair at Harvard, who are looking at the epigenome as a key also to perhaps even reverse aging. Yeah.
No, I mean, it's such a mind-boggling area of study, right? And I mean, just the idea that a whole human comes out of a single cell with DNA that basically on its own accord, give or take, creates an entire human structure with all the organs and viscera and skin and all the internal workings and a brain, and that is cohesive and works as a single unit, yet each cell contains all the information for every other cell and all functions in the body, right? And so it's phenomenal that even is a thing. I mean, I don't
know.
I think about it sometimes, and I don't really know what to think, because I'm like, it's so crazy that that's how things are. And you take a cell of like a what, I can't remember what the first cell of when like the sperm and ova create what's that first thing called, or whatever.
Could be the embryo, or
yeah, exactly. And it's like, yeah, well, that little spot is going to be a whole human someday. That's going to live for a long time and reproduce and, you know, be capable of all kinds of higher order thinking and processing and just an amazing like feat, right? And so, you know, I guess and you had touched on this earlier where you had mentioned unintended consequences, right? And this is an interesting part of it, which is that we don't know at this point exactly how any change will affect the system as a whole, right? And I think it's obviously, you know, the people who are doing this research have thought about this and are working to mitigate this kind of problem from manifesting or figure out how to reduce it. And, you know, I heard a doctor say the other day that in medicine, a lot of the time, he said we do bad shit to prevent worse shit from happening.
Yeah,
right.
And
it was very like a very enlightened thing to say, because what he was saying was that not only, like, sometimes medicine does bad things, right? Like, it has unintended consequences. Like, if you take, let's say, antidepressants, for example, right? And because of these antidepressants that you're taking, you have all kinds of side effects that you don't like, whatever they might be, right? And now you might say, well, why would you take it if you're going to have all these side effects? And it's like, yeah, well, but if you don't take it, you don't have the side effects, but you have a whole lot of worse things that are going to be there, right? And so you're kind of like taking a lesser evil over a greater evil kind of thing, right? And I imagine that in this genetic engineering space, similar things are going to happen where, you know, people who have like genetic malformations or different conditions will have those things repaired, and they will or probably will have unintended or unfortunate consequences because of that, but it's still probably better than had it not been done in the first place.
That's right. Yeah,
right.
And I mean, hopefully it's not the Jurassic Park scenario. That's why that movie was so great, because you know, life found its way, but it wasn't. It was a little messy there, right?
Yeah.
But a great movie, a great book actually. Yeah, you're right. The other thing is these trade-offs may not be biochemical. So it could be, for example, we spend this money doing genetic engineering to change certain human traits, but that's a lot of money we're spending, right? Which we could be. There's an opportunity cost to there. We could be spending that elsewhere. And where do we spend it? Do we spend it just for treatment of disease such as Alzheimer's, HIV, sickle cell, Huntington's, cystic fibrosis? Those, they're already circling the wagons on those with genetic engineering. But if you spend it on that, most people would probably agree with those. I think Huntington's is a horrible thing. I know a family who has that gene in their family, and one of the offsprings is afflicted by it. And cystic fibrosis. My sister used to date a fella who had that affliction, and he died, unfortunately, I think when he was about 40, which is very typical for someone with cystic fibrosis. And he had problems breathing and whatnot with his lungs all throughout his life. So those two, actually, they predict will be early candidates for genetic engineering, because in the case of cystic fibrosis, apparently it's just one nucleotide where the C and the G nucleotides are flipped, and it's GC instead of CG. And there's already a lab in Singapore that can flip nucleotides. So if they can figure out how to do the flipping safely, that would be an easier one. And also Huntington's apparently is just one gene, so that would be a great candidate. But there are other afflictions like depression, which they're doing a lot of research on, bipolar disease, which are much more complicated. They're finding that there's many genes involved, and overlapping with other conditions too. So I think bipolar overlaps on several genes with schizophrenia and also depression. But they're also separate genes for the three of those conditions. So it would be very difficult to zero in and easily change one without affecting the other. And who knows what else you're affecting? Like maybe you've solved the schizophrenia, but then there's no more creativity. Because I know it seems like a lot of schizophrenic people are very creative, and
Definitely.
geniuses, and so you just wonder about the how much they can zero in other areas. But I'm pretty hopeful. There's a lot of stuff that is going to happen. It's happening now, and it's going to help a lot of humans. There are some other issues, like should we be helping people with athletic performance? Like should we have super athletes? Because I think that's going to happen. They're going to have to start controlling that, just like they try to control steroids. I know the WADA, World Anti-Doping Agency, is already on this, because they're expecting stuff to start happening on this front.
And I mean, it'll start in athletics. It'll start in like soldiers and all like the military have a nice way of frontiering, technological advancement and things like that. And I mean, it's all part of the same thing. It's like there'll be good parts, there'll be bad parts. It's hard to have one without the other. Probably impossible. I mean, just with anything, you can take like, Einstein's work that ultimately led to the atomic bomb. It's like, I mean, it's not why he did it, but because of his work on that, there were, nuclear arsenals that were developed, but so was there enormous advances in physics and maths and things like that. And so it's like you take some good with the bad, and it's not necessarily a reason not to do it.
And I think that's really well said. It's the double-edged. I live in Ontario, and so do you, where we have one of the greenest, most pro-nuclear jurisdictions in the entire world. So I happen to be related to the head of the nuclear agency, and he said that compared to almost any country in the world, we are greener in producing electricity because we use nuclear and we use hydro for almost 80% of our energy. We don't burn coal anymore. Yes, we do burn some gas, but we're very green. And nuclear has been, we've had to come up with treaties, non-proliferation treaties. I think in 1967 was the first one there, and they even had one this year on the prohibition of nuclear weapons, although there were no nations that have nuclear weapons that signed it. It's only the ones that didn't have them. But still, I mean, we've done we've done a pretty good job containing the nuclear threat. We've spent obviously billions of dollars on the weapons, but we haven't blown each other up too many times with them. Thank God. And the atomic energy, the International Atomic Energy Agency, and the Nuclear Suppliers Group has been pretty good trying to help on that front. So I think I feel lucky that we and I think jurisdictions like ours with nuclear are going to make a comeback. I'm hearing that the Canadian government's looking at these micro modular nuclear plants now. They're smaller, more flexible plants, and other nations are starting to look more seriously at nuclear again. It's a great solution. That's cool. Climate change anyway, so
we definitely need something going on with power and energy and how we do it, and nuclear at this point seems to be a great option. I mean, in my personal uneducated opinion, as not being a scientist, it would appear to me that solar energy would really be the ultimate, because it's endless, there's minimal risk, but as far as I understand, the technology that we have isn't quite up to par with where it would need to be able to harness and store enough of that energy to have it, energize cities and civilizations and things like that. But anyway, I mean, it's all interesting and it's all good, and thanks Einstein for that, and his crew and whatever it is. And so, but the world of like genetic engineering, as we've been saying, like there's going to be multiple parts that it's going to probably do tremendous good, right? So there's the medical application of it, which will be very good, generally speaking. Then there'll be the, do you want to genetically engineer your kids aspect of it, right? Do you want to custom build them? And then there'll be the, the malicious side of it, and creating this bad thing or whatever. But what I want to ask you about, or talk to you about rather, is, a lot of the time when we talk about unintended consequences, it's also from an aspect of like, well, we don't exactly know how things are going to play out or why they play out the way they do. right? And so we try and combat problems and often introduce, and which often end up just creating different problems, right? Like, so for example, I think in various places when they have like overpopulation of deer or like wild hogs or things like that, and they just run rampant because they've been introduced, as a sort of alien species, and they have no natural predators. And so in the beginning, it's like, oh, well, we're bringing this new food supply, and it will nourish the land and it'll work with the ecosystem. And then a couple decades or 100 years later, you find out, well, they're actually destroying the existing ecosystem because they're not being regulated in the sort of typical predator-prey cycle. And so we try and, solve that problem by introducing predators to them, like wolves or bears or whatever it is. And then that works for a little bit, but then all of a sudden you have this giant population of these wolves or bears that are now so numerous that they're causing other problems, right? Like they're killing people and they're ruining sites and things like that. And it's like we do all these little tiny manipulations of, large ecosystem structures that are done with good intention, or at least neutral intention, that have good effect, but also then have some huge problem, right? And it makes me concerned in the area of like, what do they call it when you like designing your designer children or whatever they call it, where you'll get to theoretically be able to pick out certain traits and characteristics and do genetic engineering on your future children. And it's like, yeah, but what that probably in my head turns out to be is that there's going to be a bunch of people who think that certain traits will be most desirable, and they will be for a little bit, but if everyone chooses that, then there's going to be this huge lack in other areas to balance our society, which require different traits that aren't typically thought of as beneficial, or not beneficial, but like the most appealing, maybe you could say. And so, it seems easy that we could easily create this imbalance. Not that we have balance right now, but I mean,
I like the way you said that. But what will affect whatever we like? There's an interconnectedness to everything, right? And I think that's what you're saying. So if you change X, then Y, Z, and Q will probably also be impacted, and you better have an idea how that's going to play out. And one of my characters in my novel, he's very Buddhist-like. He's an older fella. He goes for age decoding, so his aging is stopped at the age of 76. It's offered to everybody, so he goes for it. And it's not such a bowl of cherries living for that long. So he lives another 200 years, and my novel stretches another 200 years past the invention of age decoding. So it goes from 2053 to 2256. And so you get people that get to experience living. So does he. He's 76. He's not getting any younger, but he's not getting any older. And so he philosophizes a lot, and he's sort of a Buddhist-like deep thinker, and he provides that sort of what you're saying, that voice of not just reason, but speculation about the interconnectedness of everything. He himself was a biologist, so he understands how species and animals work and how they connect through nature. And he wonders about the effects of this on nature. For example, there's going to be very few younger people anymore if everybody's living forever, right? And so you're not going to younger people will be weeded out. Most people will be about 25 years old. By the way, they also invent reverse aging later in my novel, so now people coming backwards, like he can get younger, and he's going to be the same age as his granddaughter in 50 years. So like he's thinking about these things like, do I really want to be the same age as my granddaughter? And then there's his granddaughter herself is thinking, I can't have any children. I won't be allowed to have children unless I win the lottery for having children, right? And so, and then her mother has disappeared. So she because her mother is the scientist who invented this, and she's being sort of captured by the government because she spoke out about her concerns for this. So like there's a lot of just in my novel with stopping aging and reversing it has huge effects just on these people, but also on society. And the nice thing about doing sci-fi is you can really allow people to experience just how it feels, the effects on humans, how they feel, what they're putting up with, the different the pluses and the minuses, and instead of just saying, oh yeah, this is all great, we want to all live forever, right? So that was the fun part of the novel,
right?
Really.
Yeah, and the psychological aspect is important too, and it's a thing that is fun to speculate about, but who knows how that will play out, and it will probably play out differently for different people depending on all kinds of things. But do you want to live forever? Like, if you could give yourself a timeline, how much time do you think you would?
Yeah, that's a good question. I don't think I would have written this novel if I knew I was going to live forever. I wouldn't have been so motivated. So I'm getting old. I want to get something done, right? So, just that one little thing. Would I have pushed myself to do this? And I sort of like the age group competition. If we all live forever, we can be any age. That's going to be gone, and we're all going to be strapping 25-year-olds. But so I don't know. I guess if you offered it to me for free, to stop aging for free, maybe I'd go for it. I'd go for it if you can sort of experience it, then
pull the plug,
revert back, which apparently you can do with CRISPR. Now there's CRISPR on and CRISPR off, which just come out. So you can turn it on, turn it off. And then there's also anti-CRISPR. So in case you think someone's going to do something to you, like maybe there's a terrorist virus that's going to be genetic engineered and released, there's also an anti-CRISPR they're working on at MIT, which could be pretty important in all of this, which protects you or a set of DNA from any genetic tampering.
Right. Yeah, I suppose that's an interesting problem. Like we have biological warfare. Yeah. Theoretically, we could have genetic warfare at some point, and that's messy stuff for sure.
Would you go for it? Can I ask you the question? Would you stop aging or try to reverse your age if you can?
My initial instinct is no, but I understand the appeal for it. I mean, I guess here's what I would probably say is, like you, if there was a way to switch it off or pull the plug, I wouldn't want to be immortal so that I couldn't die. But perhaps I would like to have more control over it. So let's say, when I'm 25 or 30 or whatever, I can be like, well, I want to stay in this condition for the rest of my life because it's the peak of my physical.
Yes.
Mental's a different question, but it's sort of the peak of physical, physicality. And so you want to be in your strongest state for as long as you can, because you don't want to, degenerate and things stop working as well. And I mean, it's fine if it does, because that's a natural part of, how things come into being, and then they deteriorate and then they go out of being. And so, but let's say, we could stop it there. Like, maybe it would be cool to do that and then sort of live another however many 50 or whatever years, or 60 or 80 or 100 or whatever years sort of go on. But it's an interesting thought experiment, because I mean, I've spoken to people who would be like, yeah, I want to live for 1,000 years. And I'm like, you want to live for 1,000 years? Like, that's crazy to me. I mean, good for you. Like, if you want to do it, go for it. I'm not judging. It's just, to me, that's like, whoa, that's too long. Like, I'm happy with, having a life and then having it be over, and then it just falls as a part of a bigger scheme of things. I don't know why. I don't have that drive to just live forever. But some people do. Some people do, and I hear you. That's all that's the psychological side, right? And that's only the psychological side. Think of the societal impacts of this, like I say, not having young people, not having old people either, and so you wouldn't have those intergenerational, which some people see as beautiful part of nature, with grandparents, granddaughters, kids, parents. You would lose all of those wonderful intergenerational bonds and love connections. Absolutely. And also, I mean, it would bring a weird point of, like, let's say you could stop aging until you wanted to die, and then you'd have to have some system where people basically have been like, well, I've lived my 100, 200, 300, 400 years, I'm done now, and then now it's time for me to die. And then I don't think people in their lives are going to be thrilled about that. And then say there's probably going to be a weird, like, like way of trying to navigate that, and it's like, how do you regulate that kind of a thing, and who can take that? I mean, listen, ultimately you can choose it yourself at any point in time for the most part, but generally it's kind of frowned upon in society to, take your own life, or not frowned upon, but it's like, I don't know, it's a sore spot for people.
Yes.
Even like with euthanasia, like medical euthanasia, I know is a topic that's of interest to a lot of people at the moment, even in Canada, where there's a lot of appeals, and I don't know the exact current legislation on it, but they're working towards some sort of a medical euthanasia program where people who are terminally ill or something along those lines can sort of jump the queue of when they're going to die, and have it done peacefully by a clinician. And that's going to cause a lot of problems for people, because we don't like to accept that. And if a loved one of yours is sick, and let's say the doctors give him a couple years or whatever, but you want to spend that time with them, but they don't want to spend that time living and suffering, that's a hard place to be in, right? Understandably. Exactly. For everyone involved. Hard for the person who's sick, hard for the family, hard for the, maybe not so much for the doctors, but it's a really like strange one. I mean, have you, encountered, does euthanasia come up in this discussion?
Yeah, it does. So, well, in my novel, the main character, Dr. Frieda Sengmeuller, who invents this age decoding, and she earns the Nobel Prize in 2053 for it, but she has grave reservations again about the technology itself. So she's sort of speaking out. She's trying to set up an ethics committee, moral committee, having broad consensus on how it might be used. And meanwhile, the government really wants to just ram this through and offer it to everybody, make them very popular and whatnot. So, they find a way of sidelining her. They kill her, but they don't really kill her. They just stage her suicide. But that
it's a classic government move.
Yeah, so they remove her from society. They take her underground because they don't want to lose her brilliant brain, and they want her to keep working on reverse aging. So she's taken underground for 200 years in my novel, and her daughter and her father, this Buddhist fella, both think she's killed herself. So her daughter is devastated, but in the end, her husband thinks she's killed herself too. So he goes and there's something in my novel called immortality ennui, where people who start to live it forever, like live 100 years, 200 years, start getting sort of almost bored with life. With infinite time doesn't have as much value if you have almost boundless time in your life. So they can go into what are called these specter societies, where Lolita the robot or whoever will bring you in and wine and dine you or whatever for your last moments, and then you kill yourself. So he goes into a specter society. One of my favorite chapters of writing was him going in, marching right in there, and signing up for the procedure and all that, and then going through everything, getting ready to kill himself, have Lolita kill him. But because he thinks his wife has killed herself, so he wants to sort of join her and think now it's early in the novel, so I'm not giving too much away. He backs out just at the last minute. He just sort of, Lolita, I'm out of here, and turns in the other direction, and the robot can't do anything. She just says, but that's
see you later.
So that he almost did the euthanasia to himself, but he so
something stopped him.
These are really important considerations. Like if you have there's a quote I could read if you don't mind from the book.
Please do.
I could find it here. It's this fella again, the philosopher fella. His name is Jesus. Even though he's Buddhist, he ironically his name is Jesus. But he says, humans with so much time naturally avail themselves of it inefficiently. Anonymous once said, the thief to be most wary of is the one who steals your time. But with age-decoding genetic engineering, I believe it's the opposite. I think the thief to be wary of is the one who lends you too much time. With with too much time, they steal your humanity.
Right.
So that's what they're stealing. They're giving you too much of something, which is stealing your humanity.
Yeah. And it makes sense, because part of being human is aging, right? And people resist it heavily, but you can't get around it.
Yeah, and this is brand new. Like, we have not done genetic engineering on ourselves. We've done genetic engineering on crops and breeding dogs and things like that, but that's slow engineering. This can be very pinpoint, very exact, very specific, and very rapid. And this is crossing into a completely new territory for humanity. Here's that word, humanity again, because we are going to be changing human nature, literally changing the code, the backbone of humans, not nurturing them. We're changing their nature, and that's a whole different ballgame.
Yeah, and it's probably going to happen faster than it should. And what I mean by that is, and I'm sure you probably agree and have thought about it, is that the technological advancements will come quicker than any regulatory body or ethics committee or anything that can stop it. I mean, just as a cross comparison, you can see it in like artificial intelligence, right? Where we're probably going to reach a point that a point of no return that we shouldn't have crossed, but we didn't know perhaps not to cross it, or no one was checking up on that, right? And that could be potentially dangerous. And so something in genetic engineering could similarly happen, where something becomes available, and in virtue of the fact that it's available, it will be used and aggressively and reproduced and unregulated for a period of time, and that'll have all kinds of implications until more information and regulation and ethics committees and all that can be set up to properly navigate these things. Right?
And that's precisely what happens in my novel. So I wanted to bring that forth, and in my book, I wanted to show a couple of examples. So the aging thing is the obvious thing. It's a physical thing that was changed, and it was not a bowl of cherries just stopping aging and reversing it. But that's a physical change, genetic engineering. So, but I also brought in a psychological one, which I can't say too much about because it's more of a
read the book.
The mystery, the scandal in the novel. But even Jennifer Doudna, who won the Nobel, I mentioned her before, she did say that genetic engineering could be used clearly to affect psychological traits too, because a lot of psychology is connected to genetics, right? So
definitely, it's all connected. We're one being. We like to separate it into bits, but it's very difficult. And I think more and more so in science and medicine, we're seeing that today, that your psychology and your physiology are intricately linked, if not the same thing, in different manifestations, right? And so, well, listen, I mean, you can see it. You get a brain, someone knocks you on the head, your personality can change. People have that all the time.
Exactly.
Crazy things like that happen. Or it messes up some part of your brain and you have unregulated emotion and aggression, or all kinds of things. And that's technically psychology, but it's from a physical injury. And, all kinds of brain operations that they do similarly can have massive changes, or tumors. Or, I had a neurosurgeon on the podcast a few weeks ago who was discussing how brain tumors can affect personality changes. And it's fascinating because it's like, we don't think of ourselves that way, right? We tend to, and I don't know exactly why this is, but we think of ourselves as somewhat separate from our body, but also intimately connected to it, right? There's a sense of like unchangedness, and yet in an instant it can be completely changed, and there's nothing you can do about it.
Yes, indeed.
I mean, maybe you can have some surgery and repairs, but like, at the end of the day, there's limits to all of it, right? But it's fascinating, and it's an endlessly open and interesting topic. And so, do you think that medical advancements will be the first field where we see it?
Yes, I do, because that's where most of the research is happening right now. That's where the government funding is going on. It's quite a complex of involved actors here. So you've got government funding, like say the National Institutes of Health, United States, National Natural Science Foundation, China. Then you've got the huge universities like Kyoto University, Japan, Harvard University, MIT, and others. And I mentioned University College London seems quite involved too. So that's great. So you have universities, you've got national funders, like large-scale funding, and then you've got corporations, many biochemical corporations like Intella Corporation, for example, Editas. They're quite involved. So all three of those actors are involved, and they're mainly for medical applications. No doubt about that. Yeah.
Right. At least on the face of it, right? They're saying it's for medical applications.
Yeah. But
they might know of some other ones.
Oh yeah, there might be things we don't know about, right? Like who knows? Maybe the Chinese government is doing research to make their soldiers more fearless, or like who knows? Like there's actually been a rumor about that. So
I'm sure all governments are doing that.
Yeah, and
to be fair.
Yeah, and well, maybe there's I hear. Well, they say that some athletes are already ingesting substances that they think will change their genes. So individuals are trying stuff, messing around with stuff already. And so, there are going to be other actors. If I could put a plug in for one of our Canadians, there's a female researcher, Francois Baylis from Dalhousie University in Halifax, who just published a book. It's nonfiction, but it's Harvard University Press, and it's called Altered Inheritance. And I just read through it. It's fantastic. She talks about a lot. She is a geneticist, and she talks about this side of it, like the moral issues, the ethical issues, the messy stuff. And she thinks it's going to be tough to control, and that we're going to have to. She's been involved in some of these committees that have met and made declarations and all that, but she said that's not going to be enough. We're going to need a lot of players, not just corporations, not just politicians, not just scientists. We need regular people getting their input on this. And she's a little worried about it, but she also made some good recommendations. And she's that's a good book, and I recommend it for anybody who's really into this stuff. Altered Inheritance just came out from one of our Canadian profs. Yeah,
that's cool. Yeah. No, listen, it is, and they'll probably, excuse me. I mean, the interesting part about when you have so many players in the game is that different organizations start to pitch things that seem rational that aren't, which are like, well, we need to get it first to control it, right? If everyone's doing it, then we must be the first ones to do it so that we can control it, so that it's used safely and properly. And inevitably, that doesn't work, and that's not how it tends to work. But I mean, the sentiment is good, but you're right, it's like, but what can you do? I mean, unless we have some sort of huge technological problem in the next few years, it's like there really is no stopping this, because you just need one person or one group to figure it out and tell everyone how they did it. And the internet is a beautiful place for that, and then that's the end. There's no, I mean, you would have to have a global coalition of governments banning these kinds of things, which we can't even do on anything like climate change. So what are they going to do about this kind of stuff, right? I mean, it's going to be pushed aside as not relevant or not important, or it's not as big a deal, and it'll rise, and then all of a sudden there's this catastrophe of like, oh shit, it's happening, and then you got to deal with it, in final form. But it's a complicated world. It's an interesting field for sure. And what has the response been to your book? Like, how have people felt about it?
Well, the book just came out 3 months ago, so I'm just starting to get some reviews, and nice. And it's nice. So it's one fun thing about writing a book is you actually have someone spend 8 hours reading crafted, right? and people have said that they first of all learned a lot about genetic engineering in there, and they could visualize through the characters. A lot of people talk about the characters, some of the positive and negative implications, and the story has enough. The story has enough twists and turns that I think, especially in the second half, it really gets pretty dynamic and some surprises. So Yeah. So and
Keeps you engaged.
And a lot of the readers aren't science fiction people. They're it's more of a literary speculation. That's what it is. It's not so much that, like I said, that it's not on another planet, that there's no aliens involved. It's more of a you know, let's take a look at this science here, let's see what might happen. So that's refreshing. Seems to be more middle-aged so far, middle and older, I would say. So I'm
that's
trying
surprising.
to. Yeah, I was sort of surprised too. Although I think it would be great for a younger person, maybe not a 12-year-old, but say like a mature 16 or 18-year-old would get a lot out of it. And that's the generation that's going to live with this. Like I'll probably be 6 feet under and you know, long gone when this stuff actually comes in, like especially anti-aging and all that. But they're a generation, the young kids people in their 20s and 30s, they will, I think, see a lot of this. And, so yeah.
No, that's awesome, and congratulations. You know, it's a hell of a thing to write a book. I mean, what did you get the most out of it? Like, what did you feel was the best part about writing it?
I liked just creating like twists in the plot and characters, like so the actual crafting
narrative
of it. The editing was tough. That was like I found that the hardest part, the editing. So where you create something that looks great, the next day you wake up and it's like, ooh, I don't know how good that is. I better show that to someone else, right? And so when you show it to other people, though, it's very humbling. So, but you have to listen to what they're saying. And I had 2 or 3 editors near the end who really helped me a lot. There's people saying, you know, this chapter, you need to expand on this. You need a couple other chapters on this. Maybe you need some flashback chapters. It's too linear. Maybe get rid of this chapter. Why do you have this chapter, this character? So I had a couple editors who were very, very helpful, and but that was the hard part, throwing out work that you've done or having to rework stuff. But I was sort of lucky because I tried to publish it 8 or 9 years ago and I had no success. I couldn't get any publisher to even read it, so it's tough to crack in as a first-time author, as you probably know. So, but so I was sort of lucky though, because what that meant is it got delayed, and I sort of put it on the back burner and went on with my life. But then I went back at it when COVID hit, and I had lots of time, and the genetic engineering has really mushroomed into a hot topic, so it was probably better it came out now. And I had to update all the science and course and then get these editors to look at it. So it's much better than it was when I first tried to release it 9 years ago. And also self-publishing is so easy now. I just self-publish. I didn't even wait. And I'm getting a print book created, so I'm working on that right now with my self-publishing platform. So I'm gonna have it's not just an ebook; it'll be a print book. And I think there is a possibility it may get published with a traditional publishing mill, but we'll see what happens there. But I'm not even worried about it. I've just enjoyed this, and doing podcasts like yours. Thank you very much. It's a great opportunity because this platform really wasn't big 10 years ago either, right? And so it's a wonderful chance to spread the word about your novel and get people interested in it and talk about it, and the conversations are great.
Yeah, no, it's fantastic. And, it's amazing that we live in a world that you can self-publish, go on your own press tour, do however many podcasts or, web shows or whatever you want by yourself. You don't need booking agent. I mean, maybe you have, but technically you don't need a booking agent any third party in the middle of publishers and things like that. You can just be like, no, I'm going to do it, and I'm going to go spread the word, and a bunch of people might buy it, they might not, but it's all, comes back to me, and that's fantastic. And it can pick up, and it can, become huge. Like, you don't even need, as you say, an ebook. There's no storage, there's no shipping, there's no any complicated logistics of how to print books and things like that. It's like you can just create a piece of art and just show it to the world and say, what do you think? And get all of the amazing things that come with it. So a huge congratulations to you, and thank you for coming on today. I appreciate it. It's been a great conversation. I'll include the links in the description, but just quickly, like, where can people go if they want to get it?
Sure. Yeah. They can check out that link. That'll be a common link to a lot of places like Amazon or Apple, or their favorite retailer should be on there.
Okay.
The novel is called Age-Decoded. There's a hyphen in it, so it's Age-Decoded. And if they just type that in and on Amazon or Apple, it'll pop up. It's got a nice blue cover and sort of a futuristic design there. And so they can search for it that way if they want. And I just wanted to thank you again for the opportunity and for allowing me to join Underground Antics, and keep up the great work with your show, Shane.
Thank you. Yeah, and I hope to speak to you again soon. It was a pleasure. All right.
Okay. Thank you.
Thank you. Take care. Hey. Bye.